Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera. In this video, we'll discuss two questions on chapter 7, Gravitation. So let's start this off with question number 1, where we have a rocket of mass 2.4 to the power of 4 kilogram traveling from the Earth to the Moon. Mass of the Earth and the Moon are 6 exponent 24 and 7.4 exponent 22 kilogram respectively. So let's list down the information that we got from the question. Mass of the rocket, I'm going to label it as MR 2.4 exponent 4 kilograms. Mass of the Earth 6 exponent 24 kilograms. Mass of the Moon 7.4 exponent 22 kilograms. Okay, for question number 1, what's the magnitude of gravitational force of the Earth on the rocket? So force of the Earth on the rocket. Okay, because when we are determining gravitational force, it has to involve two bodies. So in this question, it's referring to Earth and the rocket. So you have to have two masses. So to figure FER, they gave us distance 1 exponent 9 meters from rocket to the Earth. Okay. Then number 2, determine distance of the rocket from the Earth. Okay. So let's try number 1 first. This is very straightforward. We just take FER and write down the formula. General formula for gravitational force is G m1 m2 divided by r12 squared, where m1 is mass of the first body, m2 mass of the second body, r12 is distance of m1 to m2. We are measuring it from center to center. So for FER, it's G, mass of the Earth, mass of the rocket, divided by distance between Earth and rocket. Remember to square that value. Okay. Because students often left out this part of calculation. Okay, jangan lupa square lah. Okay, G kita ialah constant. G is 6.67 exponent negative 11. Mass of the Earth is given 6 exponent 24 kilograms. Mass of rocket, way lighter than the Earth, divided by RER is 1.0 exponent 9, then square. Plug in these numbers into your calculator and you'll find that FER is 9.60 Newton. Since the equation is just asking for the magnitude, so we don't have to include direction of FER in our answer. Okay, so let's move on to the second question, where you have the rocket traveling along the straight line. So we are assuming rocket is traveling in a straight line from the Earth to the Moon. So this is the straight line that we're talking about. What's the distance of the rocket from the Earth? Okay, rocket to the Earth is this distance, center to center, yeah? So let's call it X, maybe. Okay, X. So distance of the rocket from the Earth is what we're trying to figure out, and the question tells us that gravitational force on it. What's it? It refers to the rocket. Okay. By the Earth and the Moon, they are of the same magnitude, meaning FER, the value is exactly equal to FER is equal to FMR. Earth and rocket, Moon and rocket. So it's the interaction between two bodies. Kalau macam soalan satu tadi, dia cerita Earth dengan roket kan. Okay, so kita kena tengoklah dia tengah cerita pasal siapa, sebab nanti kita tahu what values we have to substitute. So for number 2, actually we have another information that's given in the bracket. Distance on the moon from of the moon from the Earth, which is this distance right here. It's let's call it R, small r, 1.5 exponent 11 meters. Okay, what about this distance? They're not given, it's not given to us, but we can figure it out later in our calculation. Okay, so number 2, using this equation that I wrote down just now, FER is equal to FMR. Okay, formula dia apa? GMEMR, sebab dia adalah interaction between the Earth and the rocket that's travelling from the Earth to the moon. So divide RER squared equals, kenapa equals? Sebab dia kata they are of the same magnitude, they have the same values. Okay. Then on the right hand side we have GMMR divided by RMR squared. So look at your equation. Because G appears on both sides, so G tu kita boleh cancel out. Apa lagi yang appear on both sides? Kita ada MR. Okay, kita cancel so that we can simplify our equation. Nanti senang sikit nak kira, nak masuk calculator. Then we're left with ME. RER tu tadi kita panggil X ya. Ini RER, between Earth dengan rocket. So saya panggil dia X lah, senang sikit. Okay, X. Lepas tu MM. Okay, macam mana pula dengan RMR? Okay, mass of the Earth, ini dia dah bagi dalam soalan, so tak ada masalah, nanti kita boleh substitute. MM pun dia dah bagi dalam soalan, cuma RMR ni mana nak cari? Dekat sini kenapa? Let's think for a second. Why they give us the value of distance of the moon from the Earth, 1.5 exponent 11 meters tu? Kenapa dia bagi kat kita? Okay, because we're going to use that value in solving number 2, in solving for X. Sebabnya kalau dekat sini 1.5 exponent 11, dekat sini X, jadi kat sini berapa? Okay, saya bagi simple example. If I have 5 meters here, distance from this point to that point, dan kita ada another object in between, dan dekat sini 2 meters. Kita boleh cari tak distance dekat sini? Jawapannya boleh, sebab kita just subtract 5 minus 2 dapat 3 meters. Okay, jom kita apply method ni dekat kita punya distance. Jadi kamu akan dapat apa sebenarnya? X plus dengan yang ini apa? Yang ini distance from rocket to the moon. So RMR tadi kan? Okay, X tambah dengan RMR, kita akan dapat dia equal dengan 1.5 exponent 11. Macam ni tadi, 2 plus 3 kita akan dapat total dia 5. So I'm doing the same thing here. In order to find X, or to express the value in terms of X, to make your calculation easier, then kita akan dapat 1.5 exponent 11 minus RMR. Okay. Oh, sorry. Is it correct? Yeah, I think so. So kita sekarang nak value RMR lah sebenarnya. Sorry saya betulkan kat sini. Kita nak in terms of X. Sebab nak X dia tinggal dalam calculation kita. Tertukar kat situ. Okay, kat sini kamu boleh letak 1.5 times 10 to the power of 11 minus X square. Okay, square bukan untuk 1.5 dengan X tu, dia kena dekat luar, because the whole thing in the bracket is RMR. So we are squaring RMR. Okay, lepas tu dekat sini dah ada Kalau tengok dekat equation kita, kita hanya ada satu unknown. So, bolehlah cari value X berapa. Kamu kena berhati-hati dekat sini. From this point on, it's all mathematics. Tapi bila kita tekan calculator tu, kita kena extra careful sebab it involves numbers with a lot of powers. Yang ada power 11 lah, power 24. So, let's try this calculation to determine X. What I'm doing here is I'm going to try to invert the fraction because I want X to be on top. Nanti kita senang nak calculate. Okay. Dan dekat sini apa yang tinggal kat atas 1.5 exponent 11 minus X divided by square mm. So to get rid of this square, kita tak nak square ni ya. Macam mana nak hilangkan dia? Sebab kalau kamu square nanti dia akan it becomes a quadratic equation and we don't want that. Kita akan square root semua on both sides. Right hand side pun kita square root, left hand side pun kita square root. So apa yang tinggal kamu akan dapat X divided by square root of ME. Okay, ME berapa? Okay, ME kita substitute terus 6 exponent 24. So kita square root kan dia. Okay, equals kan dekat sini square dia dah hilang kan, kita dah square root. So kalau nak square root dia kena dua-dua belah, tak boleh satu je. So kita divide dengan mass of the moon 7.4 exponent 22. Then kita square rootkan dia. Lepas tu you can do cross multiplication. Buat macam tu, calculate, dan kita akan dapat value of X. Okay, the value of X, the answer that I got is 1.35 exponent 11 meters. Okay, so X is equal to 1.35 exponent 11 meters. This is the final answer. So yang part dekat sini kena calculate sendirilah. Okay, dia dah jadi senang je sebenarnya. Kita cross multiply, cuma kena berhati-hati dekat situ. Okay, for the next question. We are trying to find weight. Okay, this involves your second subtopic, yeah, if I'm not mistaken, acceleration due to gravity or gravitational field strength. So let's read the question first. The ISS is launched from the Earth and is orbiting at an altitude of 350 kilometers. The ISS has a weight of 4.22 exponent 6 Newton when it's measured on the surface of the Earth. Given the mass and radius of the Earth, those values are on your screen, respectively. Calculate the weight of ISS when it is in orbit. So, first thing first, altitude. Okay, what is altitude? Altitude is distance above the surface of the Earth. So you can look at this figure that I have on the right. We have the Earth and this is ISS. This is the Earth. Okay, distance from the Earth, center of the Earth to center of ISS is R, small r. Okay, but the altitude given is distance above the surface of the Earth. So this is above surface of the Earth. This would be altitude H. H is 350 kilometers. So when the question mentions about the altitude, it's actually referring to distance above the surface of the Earth. So it's beyond the surface of the Earth, below the surface of the Earth, which is from the center. Assuming this is the center, so center to surface, what's the distance? This distance is radius. Ni semua orang tahulah radius. So, kita boleh conclude that R is equal to capital R plus height ataupun altitude. Okay. So, yang ini kena faham sebab kat sini penting lah. Okay. What's next? We have weight. Weight, it's measured on the surface of the earth. So ISS ni before it gets launched to the space, to the outer space, kita measure dululah kita punya ISS tu punya weight. Lepas tu they found out that the weight is 4.22 exponent 6 Newton. Ni dekat mana? Dekat earth. Okay, lepas tu kita nak cari weight dekat mana? Orbit. Bila dia dah dekat space ni, kita nak cari weight dia dekat sini. Okay, we already know. Actually, we are used to calculating weight and we know the formula. W is equal to mg. When you are calculating weight of an object on the surface of the earth, the value of g that we take is g equals 9.81. So, on the surface of the earth, ini adalah weight dia, G dia 9.81 meter per second square. So, kita dah tahu weight, kita dah tahu G. Kita boleh cari mass. Okay. Kenapa kita nak cari mass? Sebab nanti kita boleh calculate weight dekat orbit. Sebab kalau dekat orbit pun kita guna formula yang sama. W equals mg. Cuma G dia akan berubah sebab kita is no longer on the surface of the earth. We are travelling away from the earth, farther away from the earth. So, bila dekat space, G dia akan berkurang. Okay, dekat sini W kita 4.22 exponent 6. Mass is the one that we're trying to calculate. G is 9.81. Then mass of ISS. Okay, by the way, mass is the same everywhere. Kamu dekat mana pun, kita punya mass memang akan sama. Whether you're on the surface of Jupiter, on the surface of Mercury, on the surface of the Earth, mass is something that is constant. Sebab dia adalah collection of matter ataupun collection of particles kan. Okay, jadi dekat sini mass kita 4.302 exponent 5 kilogram. Even we have travelled away from the earth, kita punya mass tetap sama. So, macam mana kamu nak cari weight dekat orbit? Kita akan apply W equals mg. Ni untuk orbit pula ya. Okay, yang tadi kita dah settle dengan earth tu. Ni number 1. So, number 2, kita nak cari weight dekat orbit. Okay, nak cari weight dekat orbit, mass kita dah tahu. G macam mana G? Okay, kita kena determine acceleration due to gravity or gravitational field strength at the orbit. Okay, where the ISS is. Okay. So, jom kita calculate G. Okay, G macam mana? G or AG is equal to G capital M over R square. So, disebabkan ISS ni dia dalam range Earth, jadi capital M tu Earth punya mass, bukan mass of ISS ya. Kat sini jangan confuse. Sebab gravity is coming from the center of the Earth. So, capital G, kita tahu constant 6.67 exponent negative 11. Mass, remember this is mass of the Earth. So, selalunya capital M ni mass planet lah. Selalunya. Okay, siapa yang, kalau kita compare mass satellite tadi dengan mass of the Earth, mass of the Earth lagi besar. Jadi, dia yang akan pull the ISS towards its center. Okay, dekat sini R kita apa? R kita ialah yang ini. Radius, which is 6.38 exponent 6 plus H. H is the altitude, 350 kilometer. Okay, kilo is to the power of 3. Sebab kilometer is not the SI unit for length. Kalau length must be expressed in meters. All the calculations that we make in physics, it has to be in SI unit. Okay, kita calculate. Ingat kena square dekat sini. Then carry out your calculation. Kita akan dapat value of gravitational strength at the orbit, and it's 8.728 meter per second square. And using this information, using this answer, we can calculate weight of ISS at the orbit. Mass of ISS is 4.302 exponent 5, G 8.728. And lastly, weight at the orbit is 3.75 exponent 6 Newton. Okay, so we got the answer correct. Okay, last question. I have another question here. Question 3. For question 3, GSAT 7A is a 2,000 kilogram satellite that is seen stationary to an observer on the Earth. It's orbiting with a radius of 42,000 kilometers from the center of the Earth. You are given mass of the Earth, radius of the Earth, mass of the Moon, and using those values, calculate the gravitational force exerted on the satellite due to the Earth. Okay. Then number 2, determine the distance between satellite and the Moon if the total of gravitational acceleration of the satellite is 0. So for number 1, gravitational force, it has to involve two bodies. So now we are talking about satellite and Earth. So F, SE, G, MS, ME divided by RSE squared. Then just substitute 6.67 negative 11. Mass of the satellite is 2,000. Mass of the Earth is here 6 exponent 24 divided by distance between the satellite and the Earth is this 42,000, because it says it's orbiting with a radius of 42,000 kilometers from the center of the Earth. So 42,000 kilo. Okay, kilo convert to meters. Then square that value. And finally, you'll get the value of FSE. And it's supposed to be 4.54 times 10 to the power of 2 Newton. Okay, now it says to calculate the gravitational force. It doesn't say magnitude, so we have to give direction of gravitational force as well. Okay, even if it doesn't mention in the question, state direction or state magnitude and direction. So it's kind of implied in the question. Kita kena faham sendiri, because gravitational force is a vector quantity. So kalau kita bagi jawapan, apabila kita bagi jawapan kita kena ada direction and magnitude and direction in a bracket next to it. Okay, so dekat sini kita dah calculate tadi FSE using the formula GMM over R squared. Now what about its direction? Okay, saya ada figure dekat sini. This is the Earth, this is the satellite, this is the Moon. So satellite dia in between. Ini keadaan dekat space lah waktu tu. Okay, dan kita nak cari gravitational force exerted on the satellite due to Earth. So kalau dia kata due to Earth, Earth is the one that pulling the satellite towards the center. So Earth tu yang akan tarik. So satellite, siapa tarik dia? Earth. Macam tu. So ini dan dia sama ya, sama menarik macam tu. Sebab gravitational force is an attractive force. So satellite akan tarik Earth, Earth akan tarik satellite. Dan ini ialah application of Newton's third law. Mereka punya magnitude sama. Okay, remember Newton's third law? Back in chapter 4 kita belajar Newton's third law. Dia kata forces kita, magnitude dia exactly equal. Kalau FSE 4.54 exponent 2, FES bila kita kira kita akan dapat answer yang sama. Cuma direction mereka opposite. So dekat sini, because it says because the question is asking you to calculate gravitational force exerted due to Earth. So Earth is the one that's pulling the satellite. Kita boleh cakap dekat sini towards the Earth. Yang ini ya, kita nak yang ini. Towards the Earth. Sebab Earth yang tarik. Tapi kalau soalan dia kata exerted on the Earth due to satellite. So satellite yang akan tarik. So kita tengok cara ayat tu bertanya macam mana. Kena faham soalan. Alright, number 2. Let's try number 2. Okay, number 2, determine the distance between the satellite and the moon. Okay, satellite and the moon. Are satellite and moon. If the total gravitational acceleration of the satellite is 0. This is quite similar to what we did in question 1. So dekat sini A dia sama. Yang tadi F dia sama ya. Okay, question 1 tadi question 1 tadi F dia sama. Yang dekat sini A dia sama. Kita nak cari R, S, M. So A Earth is equal to A moon. Ataupun kita boleh guna G. G pun boleh juga sama. Sebab gravitational acceleration tu G ya. Okay, gravitational acceleration of the satellite is 0. Okay, the satellite, siapa yang tarik dia? Earth akan tarik dia, moon akan tarik dia. Okay, so satellite dia akan ditarik oleh moon, dia akan ditarik oleh Earth. Dan dia kata kat sini total gravitational acceleration of the satellite is 0. So total G is equal to 0. Bila total G equal to 0, maksudnya G moon plus G earth is equal to 0. Okay, tengok direction ya. Ini adalah vector. So to the right, convention that we use is to the right positive, to the left negative. So G moon ialah positive. Okay, ini positive. G moon positive. Ini vector dia. Okay, G moon positive, G earth negative. So bila kita calculate, kita akan dapat G moon is equal to G earth. That's why I said they are equal. Okay. From the fact that total gravitational acceleration of the satellite is 0. Okay, next kita apply formula G M. Okay, M ini adalah G. Earth is the one that pulls the satellite. So GME, mass of the Earth, divided by R E squared equals G, capital G, mass ni apa? Mass moon, MM, divided by R M. Okay, mungkin kita boleh betulkan di sini. Mari saya betulkan kat sini. Saya akan panggil dia RM to make this simpler. So RM ini ialah RE Distance daripada Earth pergi satelit kita panggil RE. Distance daripada Moon pergi satelit kita panggil RM. Okay, so kita ulanglah apa yang kita dah buat tadi kan. Kita cancel G, dan kita substitute ME, MM. Okay, kita substitute sekarang. Mass of the Earth 6 exponent 24. R of Earth, okay, berapa? Kita tahu tak distance daripada satelit pergi dekat Earth? Ya, kita tahu. Dia dah bagi tahu kat sini. Okay. Radius of 42,000 kilometers from the center of the Earth. Ini adalah distance satellite tu. So, kita boleh substitute times 10 to the power of 3 squared equals mass of the Moon 7.35 exponent 22 divided by, nak cari RM. Okay, kita nak cari distance between satellite and the Moon. RM squared. So, kita buat multiplication. Kita buat cross multiplication. Calculate. Then, kamu akan dapat final answer dia. RM is 4.65 times 10 to the power of 6 meter. Okay. So, ini final answer dia. Yang dia bagi kat sini 4.65 times 10 to the power of 3 kilometer. Yang saya bagi dalam meter, so kita tambah lagi 3 lah. Okay. So, that's all for this video. Thank you. Assalamualaikum warahmatullahi wabarakatuh.